Claire and I have been trying to summarize the discussions of yesterday, and we came with a couple of slides to be discussed this morning with you. First of all, we tried to think what the reasons were to have aerosols on chemistry in an Earth system model. And we came with a number of reasons. First of all, aerosols are important to reproduce the temperature change in the historical period, both in terms of the direct effect and indirect effect. So it would seem a bit bizarre to have them for the historical period and not for the future. So you need some representation of aerosols to look at that. The same thing may be true to some extent for the ozone forcing, which regionally can be important. Let's say 0.4 watt per square meter globally, but more important regionally. If you want to do the aerosols in a very complete manner, you certainly need gas phase chemistry because you need the oxidants, OH, H2O2 and so on, and you need the VOCs to sort of predict the secondary organic aerosols. But then it's a question of how much complexity you want. If you think in terms of feedbacks, because that was one of the questions we had to answer, there is a number of feedbacks you can think of. For instance, temperature change will change isoprene emissions from the vegetation, will change ozone, which again is a greenhouse gas. Temperature change will change monoterpene emissions, which that can then feedback on secondary organic aerosols. You've got, of course, the famous DMS CCN cloud feedback, which is there, but we don't really know the strength of that feedback. You can have other feedbacks through changes in lightning, in fires, in wetland emission of methane, and that can feedback on ozone, methane, and biomass burning aerosols. There is something which is maybe not a feedback, but more like an interaction. Ozone can affect ecosystems, can affect growth, primary productivity, and that can then affect the carbon cycle and the capacity of land to sequestrate carbon. However, if you think that all of these feedbacks, they're not very strong. I mean, there is nothing like the carbon climate feedback that would make you think you absolutely need these feedbacks. You're talking about a few tenths of watt per square meter every time, so that's not a very strong argument. Although, it's not clear to me that all this, if you've got a large number of small feedbacks, I'm not sure they would all balance out. I've got somewhat of a feeling that there are more positive feedbacks than negative feedbacks. So if you've got many small positive feedbacks, it may end up in a larger one. So that's one reason. Another reason which I think we should consider is that aerosols on chemistry are important in terms of impact and impact assessments. From the point of view of air quality, with impact on health, on impact on crops. From the point of view of the carbon cycle, with ozone and nitrogen deposition. The question is how much of these impacts you can do offline, and how much you've got to do online in your model, because there is either because you need a lot of input, and that wouldn't be practical to save all the output from the atmospheric ocean GCM to sort of run the impact model offline, or because you need this in a very you need the coupling at a very high temporal resolution. I mean, you're pretty much interested in air quality on hot days, for instance, because you know that the weather can affect the air quality quite a bit. So that's another reason. Then, if you had the capability on the computing time, you may want to have interactive stratospheric ozone that would help the experimental design, and that would certainly help answering some question about stratospheric ozone recovery. And it's an open question whether you want to do that in the framework of IPCC or separately in a more like from a WMO assessment perspective. And then another.
Is that a positive or
No,
negative?
it's just recognition that it's been quite separated in the past, and whether it's time to get these things together or not, I'm not sure, but it's just an open question. And the last reason for considering aerosol and chemistry is because you need them to feed back some information to the emission scenario developers, because these people want to check the consistency of the assumptions with what the Earth system model actually predicts, especially in terms of air quality, because they are introducing air quality control in the model on land use as well. So we had some discussion yesterday about capability, but we didn't go very far. I think it's a fair statement to say that capability exists, but computing cost may be an issue, so we've got to address that. And there was also some feeling that the knowledge of driving inputs may be insufficient. So it may be difficult to drive the model, the aerosol and chemistry model, for the historical period and for the future in a consistent manner, especially if we go for the most complex models, which will need more driving inputs. For instance, if you go for a model approach with the aerosol, then it would be good to have not only the mass emission, but also the number emission, if you want to do that properly, because you're predicting both number and mass. And currently there is just no emission inventory of aerosol number. The validation of these subcomponents is well underway. I mean, every group is doing validation. There have been a number of fintech comparison studies, Aerocom for the aerosol, CCM Val for the stratospheric chemistry. We've heard about this new initiative between Spark and IGAC for atmospheric chemistry intercomparison. And then there is also Accent in Europe. Probably the full complexity of the model may not be required for IPC simulation. So there might be some trade-off to be done between what you can actually do and what you may want to do for in an IPCC context. Simplified approaches are under investigation at the moment. There are different levels of complexity for the aerosol model, bulk versus model, with about, let's say, 15 tracers in that case, and something like 25 tracers or more for the second case. Same thing with gas phase chemistry. We've got different levels of complexity and cost. And we can also think of different ways to couple the model. It can be a full coupling, or it can be an asynchronous coupling. And I think in the end it will be an expert judgment of what should be included, and that judgment has to be done by every group. I don't think we can sort of agree as a community as to the same level of complexity in every model.
But can I clarify, do you think, well, okay, maybe you're going to get there. It was, we're good, but maybe do you think we should agree on a common set of what might be included for some calculations, just not for all calculations, but yeah.
We should certainly agree on a set of model diagnostics, so we can make sure we can compare the outcome of the simulations, and to some extent we can agree on the inputs if there is sufficient confidence that one data set is better than the other.
And by inputs, I mean for a model comparison, what level are we talking about? The concentrations as a function of altitude, latitude, and longitude, for example, for different aerosols, or the emissions and let the models then convert them to concentration?
Well, I was thinking of emissions, but I guess there will be different groups participating in IPCC. We will have different models, and some people will probably still need concentrations, and then there is an issue on how we provide concentration for these people, like we did for the fourth assessment report.
Which we did for the what?
For the fourth assessment report, there's been a sulfate aerosol data set, which wasn't an official IPCC data set, but it's been used by a number of
That was the 2002 reference paper.
Actually, I'm referring to sulfate aerosol simulations which have been used by a number of groups who didn't have interactive aerosols.
For IPCC.
For IPCC. Yeah.
That was the Boucher and Pham reference.
Right.
Yeah.
But can I ask you, I mean, the other things that I think we might want to consider is, do we want to restrict the class of do we want to let it be a free-for-all and everybody do the best job that they can? Or do we also want to have a common set of experiments which might include more than sulfate and black carbon, for example, as changing as aerosols, which would be allowed to change through them?
Well, I'm sure there will be groups who will have more than sulfate and black carbon.
Right. I guess what I'm asking is, do we want to, so the data set that you were talking about provide concentrations for sulfate and black carbon. Do we want to expand that to a broader class of aerosols, do you think?
Sea salt, for example.
Sea salt and dust. Do we want to ask?
Certainly want.
Do we want to suggest that all groups might consider doing the prescribed aerosol simulations, even and then do the job the best way they know how?
I mean, these simulations are going to be expensive. I don't think that everyone will be happy to just run two simulations, one with prescribed and one with interactive aerosols. But you certainly want to go beyond sulfate and black carbon and probably suggest that people also consider biomass burning, even for they just use concentrations.
I think one thing that could be done is to strongly suggest that other aerosols than black carbon and sulfate are important for climate simulation, and that data could be made available to groups who don't have the capability to provide direct simulations for those.
Yeah, and I mean, that sounds fine to me, but I guess I was also thinking that maybe there would be something that would be simpler than a full simulation, which would provide meaningful information to do a snapshot calculation or something like that for pre-industrial present, and then some of the future scenarios if we used concentrations from somebody's model for future, just to get an idea of how strongly the model's response to aerosol changes is.
In other words, prescribed loadings and see how they compare.
I mean, I don't know. I haven't done this myself, but it just seems to me like it's, when David and I were talking, for example, we think that the vertical distributions of the aerosols may be very, very different on different models, and the response of the system is going to be very different depending on how the aerosols are distributed. So it's just a way of kind of putting things in a common framework.
I mean, if we, let's say we were to do this, prescribe concentrations for specific aerosols, have the different modeling groups run them, what would we be testing? Well, one, we'd be testing how the radiation scheme handles aerosols, but do we also prescribe the optical properties we think the aerosol should have, or do we leave the radiation schemes to do what they feel like doing? And then what we would be getting is what are the feedbacks the different models have in response to this forcing. So in effect, it would be almost like a feedback experiment, just estimating the magnitude of the feedbacks in the different models.
And so you would do those for, as Phil said, just snapshots, pre-industrial conditions and present-day conditions as a way of testing.
If you want to look at feedbacks, you need at least a slab ocean model. So you're talking about a significant amount of simulations and computing.
You want to look at the radiative effects. One way you might think is to have a radiation intercomparison.
Well, certainly those are also going on.
And in which, specify aerosol loading, perhaps even specify clouds, depending on how complicated you want to look at it, and then sort of evaluate what individual model of radiative transfer codes produce for radiative heating profiles under surface fluxes. That could be a first-order comparison of the radiative response. It won't give any feedbacks, but it'll give you kind of
to some extent, it's been done in Aerocom. Aerocom has been as far as radiative forcing for the direct effect.
So maybe that's an example that could be drawn on for a broader context.
I guess we.
But we could go beyond what Aerocom has done. If you were to do the prescribed aerosol loadings, then you could also, if you allow those to provide feedbacks onto drop activation, for example, you can get a feel for how the indirect effect is going to operate in the various models also. I mean, I don't know what you could talk groups into doing. I don't want to suggest things which are unrealistic or uninteresting also.
With the hindsight of Aerocon, there's been a lot of enthusiasm in the first couple of years. And then that enthusiasm has sort of decreased. We learned a lot, but then the momentum died. And we've tried to do something on the aerosol indirect effect, which was led by Joyce Penner. But that was already 2 years from the start of Aerocon. Only 6 groups participated in the aerosol indirect effect intercomparison.
If you remember, Alan Robark ran this comparison of models with volcanic aerosols. And in some sense it was a simpler experiment because volcanic aerosols have a short time span for staying in, so you didn't have to worry too much about ocean adjustment. And so what he wanted to do was prescribe the way the different models should do their radiation for these aerosols. In other words, what data he would provide, and the model should use that. So I know he came to GISS, and people at GISS said, but our radiation scheme actually doesn't use that sort of data. It uses this type of data. So he said, well, you have to change your scheme to use this sort of data. So you can imagine that never happened. So also, if we want to get beyond just concentrations, then we have to take into account that different schemes do things different ways. So maybe keeping it simplest would be best for this stuff.
Yeah, I would add for that, when we talk about aerosols, something that could also be done for the groups who don't have full chemistry, for example, would be to have pre-calculated OH, the same way you did the pre-calculated SO2 or stuff like that. And because not all groups will have a full chemistry or a simplified chemistry even in the model. So at some point there could be some pre-calculated either OH or production and loss for ozone and stuff like that. It would be the same way as was done for aerosols.
So pre-calculated aerosols for the groups who don't have interactive aerosols, and then pre-calculated oxidants for the group who have
don't have
interactive aerosols but not interactive chemistry.
I think this is possible. Not difficult to do.
Yeah, that makes sense. Then we thought we may want to fill up that table to answer one of the questions we had yesterday, and we left it blank because it's got to be done as a group. Do you want to go to the last slide? I think we've got one more. And then we touched a little bit about the experimental design yesterday. We thought the consistency between historical and future emissions was important. We said that historical emissions beyond sulfur need to be assessed, especially biomass burning aerosols, where this seems to be quite some changes since the last assessment report. Historical and future of land use, which includes knowledge of ecosystems, and that's important to estimate the emissions of the natural species. I left it as a question mark. What is the appropriate level of guidance that we want from IPCC? Should it come from IPCC or should it come from us? Do we have to take that initiative? And then there are other groups interested in aerosols on atmospheric chemistry, and we haven't liaised with them previously, at least not in an IPCC context. And that's, for instance, the long-range transport, the long-range convention for transport on air pollution, or something like that. Yeah.
Okay.
Yes, still?
Just wanted to make a comment before I go back to the other group. On one of the points of what inputs are needed, it would be useful to get some guidance on what modelers do want in terms of emission scenarios. And for example, in our work, we've tended to provide high and low level sulfate emissions, but in the IPCC, that wasn't done because, it was hard to do with different modelers. So that's one of the types of things, if that's particularly important, then we would need to know ahead of time so that modeling groups could think about, breaking that out, coming to some common definition of, what we count as high and what we count as low, or at least define what we do. The other things I can think about for reactive gases, we just did VOCs. So, and I already know that there's interest in having, at least several groups of compounds, and we do know the sources. So, would you want us to figure out groups of compounds, or would you rather us say, well, here's transport emissions, here's fossil fuel, processing emissions, and here's other, or which way would be easiest for the community to deal with? Another thing is we will probably have, and other groups have been maybe doing this too, but putting in, for example, aircraft emissions explicitly. So obviously a portion of those are at a different altitude. Is that something that's important? How important? So in a sense, how important are these things to different components? Are these, and how important are these different things for, get out in the next, year versus, past this immediate process?
Okay, I would respond to that by saying that I think the primary things we would need are emissions of other things than just sulfates for aerosols, like black carbon and things potentially even affecting organic aerosols, and also past emissions as well as future projections.
Yeah, and the past emissions, that's a real. Okay, sulfur, I have a historical sulfur projection for 100, for back, estimate for 150 years, gridded, rough way. So that's relatively easy. Black carbon and organic carbon are much more difficult. I know that Tammy Bond has been working on that, but I don't know that there's any funding. There's actually never been any funding to do that. So, that's been a barrier, and it's that's a much more challenging task. And then for the reactive gases, there's some stuff from Hyde and Edgar, but I haven't done it. So that's, in some sense, that's a separate task. It's a different community that does that.
And it's one of the problems that there are several historical missions being built now. They should be ready at the end of the year or early next year. The problem is that it's done by totally different groups from the people doing the scenarios. And at some point there should be some connections between the groups, because there would be maybe 2019 will be there and in yours will be there. So and at some point, and this has not been done at all, I should say. So it's completely different groups.
And I don't know the extent to which there's historical emissions going back in time.
1900 or 1850.
Yeah, so who's doing that? Or?
We are doing that.
Okay.
And there are at least in Europe there are two groups doing that. So our group and the group in GRC in Italy.
Yeah, so for us, it's pretty easy. It's pretty easy to sync up with an emissions inventory as long as we can get, the data. Basically, the one problem we've had historically is the emissions inventories are done by substance and country, and sometimes, but really what we need is by fuel and source sector. So if we have an emissions inventory for our base years by source sector and fuel, that's very easy to put into the model. And that's what we calibrate our emissions factors to, and we can go from there. So, and actually that's true for all the modeling groups. The integrated assessment models in general can use that sort of data pretty readily. So we just need to get it. It's been hard to get at in the past.
So in your model, what is the level of complexity in the sectors? Neki was showing transportation and industrial processes. Is there a level below that?
It varies quite widely between the models. So, for example, in our current transportation, it's just sort of a global trend. There's almost always level of detail by fuel. So there's transportation, and then there's different fuel uses, at least by petroleum, ethanol, that sort of thing. Now our current model that we've had for some time has just an aggregate transportation, but we've been working to break that out so that we have air, light duty vehicles, buses, trains, ships, so that gives a better energy system modeling, and it also gives us better resolution on emissions and what types of emissions come from where. So, industrial sectors are generally very aggregate. That's a challenge with VOCs. There is a big chunk of VOCs, which is sort of generic industrial emissions. However, most of the models do separate out petroleum refining because they're energy models. So that's a chunk that is more explicitly represented. and it will vary by model, but the more detail we have on emissions, then the models can adapt those as best they can to the detail that they have.
I do think it would be useful to, well, we may want to have this kind of a conversation when the two groups get back together and report, but I think it would be useful to have some component-wise segregation of the emissions so that we knew whether they were fossil fuel emissions, whether the organic carbon was a fossil fuel.
Yeah. Well, I was going to bring that up. I mean, it's very easy. Obviously, when we do the emissions, biomass burning, open burning is separate from fossil fuel, so those can be provided separately.
And I also think that it would be useful to have, I know you've done it in the past, but I want to just, you mentioned it already, that what information we have about injections at altitude do make a difference to us as well. So,
yeah, I think that'd be very valuable to come out of this.
Especially with fires.
Yeah.
If you think that there can be any, I mean, presumably agricultural fires have an injection altitude that's very different from forest fires, for example. And if you're going to characterize both of those things, then maybe it would be useful to know. It's probably beyond the scope of the thing.
Maybe knowing that there are agricultural fires versus forest fires or savanna.
And then the modelers may need to deal with that however they wish, however they think it's best. Yeah, I won't be here. I'll have to leave a little bit, but definitely we can talk later. I think that'd be a good outcome because then we go back to it.
You had something.
Yeah, I have a naive question. If you left different groups, so Alexander, CCS, GIST, to estimate these past emissions, perhaps the future ones, would those estimates be out by 10%, 20%, factor of 2, factor of 5?
We're not going to estimate the emissions. We're going to take what's available on the market
Yeah, but we didn't do that for the fourth assessment.
You said in one of the previous slides, we don't know the inputs.
But I can answer that question in a sense. I mean, what would happen, for example, I know it probably price to other groups, because historical black carbon wasn't available, it was scaled to population or something like that. And, that's obviously simplistic, but that's sort of the level of detail that, a Earth system modeling group is going to be able to do. And then, luckily, since then, there are groups that are working to do a better job, and, those are what would be used instead. Does that answer your question?
I think for historical sulfur emissions, there is now a good agreement between the different inventories which are available. For the future, I hope.
Well, some of them, like BC and OC, there's still huge uncertainties in emissions. So
sulfur.
You just said
historical sulfur. There's a good
sulfur,
agreement in between the groups. Yeah, as you say, historical BC and OC, they're still probably factor of 2 wouldn't. Yeah, around the factor of 2 difference.
For the fossil fuel.
Fossil fuel burning is another story. We don't even know in some places the trend.
That's right.
For all species, for them.
Yeah. And then
So I would actually, I think I asked this yesterday, but let's ask it again. How important is it that the various groups contributed to an IPCC report use the same past emissions and the same future ones for this particular problem?
I'm a bit nervous that we would all use the same emission because it sort of decrease artificially the uncertainty.
And because it is so uncertain, you don't want to do it.
You do not want to do that.
But we should certainly,
unless you're doing an explicit intercomparison where you do want to use them, if there's a reason for it, but in general you don't.
So maybe the work within IPCC could just use what is done with the CTMs, like was done with Accent, for example, which was intercomparison of the result of the models using all the same emissions. But it was just an exercise with all the chemistry transport models. But this can be used to look at the importance of having the same emission on all models and so on, but I don't think you want to impose specific emission for IPCC.
I think if you want to do an intercomparison, it probably doesn't matter all that much which estimate you would use, as long as everyone uses the same. And I don't think the response will be
But I do think it would be very
Drastically,
interesting.
very
I mean, another thing that's come up in the last few days was, I think it would be interesting to do a calculation where all the modelists use the same emissions, and you looked to see whether how their ability to reproduce the man hockey stick time series differed from their best efforts with whatever emissions that they, and solar variability and volcanic eruptions that they liked that they used for their standard model. I think it would be informative to see how sensitive it was to their prescription.
So how would you establish a way of choosing these emissions?
It doesn't matter. You just
Well, each
choose
group
one.
would want to use the one that they had used, which seemed to give the right image.
So,
But it
Doesn't
I mean,
really
there is
matter.
a community.
I mean, as long you can demonstrate that you can do a good job, but you also demonstrate then how sensitive your good job is to the emissions.
I mean,
Yeah, it does seem to me you want some way of separating out the spread due to the emission uncertainty and the spread due to the various treatment of the aerosols.
Well, models could also do an experiment in which they just don't put in aerosols for that hockey stick type thing, and just see what difference it made not using any aerosols. And let's see what the impact the aerosols had was.
I think that's a really good idea, though, to have at least one experiment for intercomparison purposes that uses a standard set.
so this also means, all this discussion, I think it means also that the emission community has to do some intercomparison of what is on the market now over the next year or something like that. Because this has never been done. And we have the Gaia meeting, which is all the emission community in November. And it's something that maybe we should really propose and having something done before next summer or something like that. A detailed intercomparison of all the emissions. And this is doable, I think. The global emissions, I mean, not the regional, because it would go far. But this we can do easily, I think.
Okay, so it's about sometime after 9:12. So we have maybe 1 hour left.
And we're
Yeah, and now
Next 6 months.
we thought that we could discuss today, but
for the last hour, maybe we could try and answer the questions, or say we can't answer the questions and move on.
I don't know. This is our way of phrasing the questions of Jerry.
Yeah. Okay, I guess the first question is this a good question?
Yeah.
Do we want to try and answer this? What is ready to go into an AOGCM and what is the highest priority?
I actually wouldn't. I would put two categories here. I'd put something like on the order of a year or so, so that could go into the next IPCC models and beyond that. If you were going to split this up, that's probably what I'd do.
I don't get it. You want to restate it again?
Yeah.
I
Plus 1 year, 2 years?
So 1 to 2 years, and after 2
No,
years?
I would say have two categories. One is a year or so, which would be what would go in. People are thinking that for the next IPCC round, and then a time scale beyond that.
That makes sense.
Would you look at it that, supposing I have a model in which I could put an aerosol package but don't have one, but could borrow one from somebody, then there would be an implementation which could be a year? I guess it would be longer.
it would be longer than that.
I guess it would be 3 years.
You're going to borrow someone else's.
So what does it ready mean then? Does ready mean that there are models with these packages operational, a critical mass of these models? Because there's only, I think there probably is a critical mass of models with all these capabilities, but that's a
And then another component of ready is you may have such a package, but boy, the computer time to run the whole package means that you can run it for a year, you can run it from snapshot, you're not going to run it from 1850 to 2100, no way. So is that ready or not ready?
No, but doesn't ready mean
Well-
you actually have the capability to do this?
Including the computer capability.
Principle, given the computer resources. I mean, everybody is,
I think there is one thing that could be ready for the next IPCC, and that is thought to be used maybe for the next IPCC. That would potentially be used. I think it is pretty clear that there would not be any interactive chemistry with full chemistry, full set of aerosols that we would run for the thousands of years that we would run for IPCC, because the cost would be prohibitive. So that's kind of just a rhetorical question to ask.
By the way, just as an aside, in the IPCC document, which it talks about models, a lot of time is spent talking about model capabilities that are not used in the AR4 models. They're models for exactly this reason. They're either newer models or models in which you have the capability, you just don't have the computer time to run something like that. So a good portion of that chapter is a bit misleading, because it almost looks like, hey, these great capabilities are what you're going to see in the model prediction chapter and you don't. Yeah.
We could have done all those things.
Yeah, that's right.
Okay, well, I think this is an appropriate conversation. It seems to me maybe what we could talk about under at least both of them would be, do we want to take a stab at doing more than sulfate and black carbon? Do we expect that we will be able to do both an indirect and a direct effect? If we do the indirect effect, do we want to allow for, do we have to allow for other things other than sulfate and black carbon? What do we want to do about organic carbonaceous aerosols? I mean, do you think those are, do you know what you guys are going to do with respect to those things?
Yeah, approximately. Yeah.
Do you know what GIS is going to do?
Yeah, in
I'd like,
fact,
well, can you just tell us?
so
We have to keep it brief.
GIS has many different aerosols that
Right.
we use. Organic, sea salt, dust, black carbon, various aerosols. We've done experiments in the future with future projections for these aerosols, as well as past use of these aerosols. Some might say foolishly, having done this, because what is the accuracy of any of this? Who knows? But we have stepped into the water to do it, based on sort of aerosol models that were run, I guess, using prescribed emissions that, like Joyce Penner came up with for one thing or another. And we've run with and without these aerosols. We have an indirect effect, which is very simplistic. And sometimes when you use something that's really simplistic, it's very misleading more than anything else. But we know what we could do if we really had a lot of computer time to make it more sophisticated. I'm not saying more accurate, but at least more sophisticated. But we're not going to do that at this point because it's just too much computer time.
Okay. So what are you going to do?
So we'll stick with sort of it. Right now, where the real focus is on trying to include the indirect effect in convective clouds, in addition to Lloyd's clouds. And again, in a very sort of simple way with sort of an estimated vertical velocity, and precipitation efficiency, and things of that nature. All of these things just sort of plucked out of parameterizations that one person or another has come up with. So what we're doing is we're sort of putting down a benchmark in a number of these different areas. The indirect effect from different types of aerosols, the direct effect from different types of aerosols for both stratiform and cumulus clouds. That's what the intent is. And presumably for AR5, for anything we do in the future, it will include these things maybe a bit more sophisticated.
Okay.
But again, not a whole lot more sophisticated because the computer time is just not there.
So you said different kinds of aerosols. Are you going to do more than sulfate and black carbon?
Oh yeah, sea salt, dust.
So you're going to allow those to
Organics.
dynamically evolve?
Yeah.
Okay.
But this is after.
No.
No, already in this
This
one.
is,
Yeah.
I mean, in fact, we're already doing this
Yeah.
so we will undoubtedly do it as one of the components. Now, the thing about AR4, was that we were supposed to run specific experiments. And so what we did is, in addition to those specific experiments, we did these other experiments where we put the aerosols in. I don't know how we characterized it. Did we say this is really A2, or did we say A2 had just this in it, and then we did these other things for sort of an expanded A2 or something like that? I'm not exactly sure how.
You haven't run the full period.
No, we did.
Oh, you did?
Yeah. I mean, you have to ask yourself, at what point does audaciousness mean foolishness?
Mm-hmm. I completely agree. I mean, all I'm trying to do is to get an assessment of, I think most of the models were extremely conservative last time. I'm trying to figure out, are we going to go how far beyond that do we anticipate being able to go for the next IPCC?
You know, there are tables that have been put together. For example, the CCSP report, one of the reports that's out already, actually has a table of what different models use for different aerosols for the historical time period. And whether they use direct effect or indirect effect. That table exists, and actually a number of models did use a lot of different types of aerosols, and also direct and indirect effect for the historical time period. What they did for the future, I don't know. We've been trying to track that down. And most people, I think, did not do much for the future. They stuck to the IPCC scenarios. They didn't put in, they kept their more exotic aerosols just fixed. I'd say that's the impression.
I can tell you what Alessandro did in the fourth assessment report. There was interactive sulfate on BC. There was biomass burning for the historical. I'm not sure there was biomass burning for the future. There was sea salt, interactive sea salt, but in a diagnostic manner. So it's not a prognostic variable. It's not transported. It's just diagnosed from the wind speed.
So we do.
Yeah. And there wasn't dust. And there was indirect effect from sulfate.
There was or wasn't?
There wasn't.
Wasn't.
And there was an indirect effect from sulfate biomass burning on sea salt. What we will do for AR5 is we've improved, we still stick to a bulk model. But we've improved the sulfur cycle quite a bit. We've improved the biomass burning. We're introducing fossil fuel organic carbon, which wasn't there before. We stick to the diagnosed sea salt, but we will have a prognostic dust with prognostic emissions. We've got a climatology of secondary organic aerosol for an ecosystem.
Sorry.
We will have a climatology of biogenic organic aerosol. That's not going to change with time. And we make some changes to the indirect effect, but still very simplistic approach, empirical approach. And that will be for historical and future. So these are basically our plans. And we're running at the moment slab experiments to see how the sea salt and the dust are going to respond to climate change and make sure we don't have some surprise when we run the
Right.
And the dust presumably would be a function of wind speed and ground wetness.
Yes, as well as the vegetation cover, which will be interactive.
Only for the future? Or are you going to allow the vegetation?
Historical.
Yeah.
And by interactive, do you mean that the type of vegetation itself can change with time?
Yes, there will be a DGVM, and the dust production will be tied to the DGVM. Well, that's the plan.
Will this, again, this is perhaps some degree of speculation, but do you imagine that this will include cultivation in which man has come in and changed the vegetation type?
We do not have dust from the cultivated areas. Dust production from cultivated areas. Right now we don't have that. I don't think that would be enough.
But when you have, in more general terms, when you have the interactive vegetation and historically at least, the vegetation is changing with time. Will it also be changing with time due to man's effect, like in cultivations?
This has been included in AR4, and I expect that we will include it in AR5 as well.
Maybe you can continue on the chemistry.
Well, the chemistry we don't know yet. It's going to depend on the cost really. And if we get a chemistry that is cheap enough and we're happy with the accuracy, we will put it. If not, we'll have to do something else.
So can I ask, in what you call a bulk scheme, do you have predictive equations for drop or for aerosol number? Or is it diagnosed?
No, it's diagnosed. Yeah, it's a mass scheme. We predict the mass of every species and then we assume a size distribution. Just to diagnose the number, and that is used to predict the coetropic number concentration.
Okay. And is that the way yours is going to work? Okay.
Again, there is, as you know, with John Seinfeld, a much more sophisticated scheme which Eric never runs.
Right, okay, good. I mean, it sounds like, I guess, I hear there are lots of similarities between the two formulations, and we're, you know, you guys are further along, I think, in defining precisely how you actually expect to do IPCC. What I can say is NCAR has the capability of running the simulations in precisely the same way, except for that I don't know whether we'll have, I don't know what we're going to do for dynamic vegetation.
That's under debate.
CCCMA also has this aerosol scheme, and we also have experimenting with dust and salts, a couple of size nodes.
So maybe what we can do then is to rather, I don't even know whether...
One difference, Phil, is that I think we did not have any indirect effect in what we did before.
No, we didn't.
But it will be included in there.
But we can easily do it now.
Yeah, okay.
Precisely, either the same way or... Yeah, the same way. I think
So all models will have mostly indirect.
Can you argue that there's now a kind of critical mass of models that could in principle do the indirect effect in some way?
Right, and I guess what we can say is these are the class of models that is likely to be ready within a year for running IPCC, and there might be something beyond that, but we don't know what.
I think there were something like 7 models for this last IPCC that did include an indirect effect.
Okay.
I think the French IPSL had an indirect effect, which was diagnosed just from sulfate, empirically, and calibrated towards satellite observations.
So maybe what we could do then, under those circumstances, is what we really ought to do is to distinguish what are we likely to do differently in the next IPCC from the one that we did in the last IPCC. Since there were those 7 models, but some of them were significantly simpler than the kind of thing that we have discussed in the last 5 minutes. Is that right?
I mean, none of them are works of art.
No.
He just ran a thing called the Art of Climate Models.
David was invited to be a speaker.
What was that?
It was one that you were too busy.
It's all mumbo jumbo.
It's okay. We'll ask you again.
Oh yeah, that's right. In fact, I said Aspen again.
Yeah, you did.
So do we want to add something, I would say, all for chemistry? Can we just say that all groups are...
Cost under evaluation is appropriate for...
But the thing is that we can, I think we should say, it's almost certain that we will do snapshot calculations.
For, yeah.
For
Well, yeah.
IPCC.
In the worst case scenario, we would do what we did for this AR4 for the 20th century. We would do it also for the 21st century.
Right.
Because I don't want to have to deal with the ozone the way we did.
With full chemistry. But
I think we should be, I think it would be useful. Let's say that we did a calculation once every 10 or 20 years, historical period, and in the future, we should be using the oxidants as they come for the aerosol package.
But in this case, if it's...
But we didn't do that.
If it's snapshots, we can do full chemistry.
mean, are you thinking about doing a full
Yeah.
chemistry
Yeah,
calculation?
it's not-
But it's not like if you do once a year for
2
every
years.
20, or 1 year every 20
The way we
Yes,
did it
yeah, you can do
for
full
the,
chemistry.
20th
And you could
century
even,
was
for
every
example,
20 years.
for tropospheric ozone.
And then we did
You can-
full
if you
chemistry for
wanted
like
to
a year or
iterate,
two. And that's enough to stabilize for the troposphere.
With a linear trend
And so
between your
that's
snapshots.
usually enough to get
Just if you wanted to add
a
those forces.
stable
Sure.
chemistry. It doesn't change. There's not that much in there for the tropospheric chemistry.
So, okay. Asynchronous coupling, you can call it like that, or
And is
Yeah.
this an issue for
Yeah.
stratospheric chemistry, is that, would that work? I mean, or can that be evaluated in some way by using some set? Some models have full stratospheric
with,
chemistry
not will.
packages that could be run in some.
will be done where,
in
will we,
comparison
yeah.
experiment to see how often chemistry has to be done.
That's right. I mean, I think until
To evolve some sort of strategy.
you get into the CFC era, then it's probably doesn't change all that much from year to year, and then you can probably just do an average over a 5-year period.
Well, for ozone assessment, I don't think that would work, because there is this issue of age where effective chemistry which affects recovery periods and things like that, so I suspect.
Yeah, we have transient simulations now with a full stratospheric model, stratospheric and above, for the whole CFC era. So we could, that tracks the history of the year. So we can restart from those, and then, so you have initial conditions that would be reasonable.
Yeah, there are a number of groups that could do that, so you could ask questions to how often. Is there a strategy for doing chemistry less frequently?
Let's look at our questions again. Number 2 was, should this component be continuously coupled or occasionally coupled and run offline? And I think we've answered that one, right? Because it sort of falls in with...
Yes and no. I still go back to the point that we were making yesterday. It kind of depends what the question is. And if it's purely the climate question, then yes, I think this answers the question. If we're trying to go beyond climate only and look at air quality and what Olivier was calling impacts, then I don't think the question is settled.
Okay, but do you think, let's say we did ask those kind of questions, would you try to do integration through a continuous integration through the year 2100 to answer the kind of air quality questions with doing a full Earth system model?
Personally, yes, because I think it would be a fascinating way of answering some questions.
It would be ideal.
Maybe we can only do it for one scenario,
There may be a small number of
but I think doing it for
if you
at
look,
least one scenario from pre-industrial through 2100.
But what would you learn that's different for that question from doing snapshots every 5-10
Because I think if you look
Because
at,
you don't get those feedbacks with the
Entirely
variation.
variability.
and also
Just do 1 year from
Yeah.
time to time.
Well,
if you look at
don't
the quality,
have an ocean involved, so you don't have coupling, for instance. You'll have to specify something if you do snapshots. You can't
Well,
do
why
it.
don't you have
No.
an ocean?
Well, how can you do snapshots with an ocean? The ocean has its own intrinsic scale.
no, the snapshots, I see it as
So,
you do full run of your model and then you inject what you get, the production and loss of ozone and so on, in the couple model, so you get all the feedbacks.
well,
But the thing, what I've seen, if you look at impacts, the problem is a lot of this health and crop stuff are episodes stuff. So if you do just a snapshot every 10 years, like if you did it in this year, in 2000 and 2010, you will miss all the problems we had
So,
over the
but
last
for
years.
that's not
So-
air quality from my point of view. Now you're talking about impacts
Impacts,
on land
yeah,
problems. Or, yeah,
No, on
okay,
health,
that's fine.
if you look around to do that, look at impacts.
well,
Crops type. I mean,
Yeah.
interactions with the biosphere.
Yeah,
that's,
just like that.
Yeah, then it gets...
Maybe, like Jean-François said, maybe just one simulation would be enough to look at that.
On the other hand, I mean, an enormous amount could be learned by doing the snapshot calculation and seeing if the ozone levels at the surface reach such high levels that they kill off half the vegetation or decrease crop yields or whatever, you know.
Well, we know that. I mean, we know that if we go with the A2 scenario and we start putting the surface ozone in the A2 scenario by 2100, that will have a very detrimental effect on vegetation. It could strongly affect the CO2s. So we know that the sign of that thing, and probably to some extent the amplitude, but we haven't looked at the overall feedback and the history and the accumulation of the feedback. Those are not uncoupled. It's not an uncoupled system.
Another thing about air quality work is that most air quality work now, at some point, inserts regional scale models, both meteorological, like FR5, and then chemical, atmospheric chemistry, regional scale models. And those, by definition, are always snapshots. Now, whether you run the full-scale GCM in a non-snapshot mode to be able to provide the boundary forcings for these regional models, that's another issue. But certainly when you get right down to air pollution, people are looking with regional models, and that is always snapshot.
Well, okay, so maybe we want to acknowledge in that table that a single realization would of an unsnapshotted model
Actually,
would be
that's
interesting, but
Now we would have cut you down.
And a lot of the addressing has to do with computer power.
yeah.
I mean,
So we're going to move on to question 3. I mean, so just we can essentially give, or let Olivier give, the first 2 slides of his presentation if we wanted to the full group. But for me right now, in terms of answering these questions, the essence of it is all on this one slide so far. Do people agree with that, or do you think that there are things that, I mean, we can certainly make more slides also, don't get me wrong, but I'm just trying to make sure that my focus, or my interpretation of what's going on is the same as everybody else's, so I'm not, or so whoever gets up there is not misrepresenting things.
Yeah. Okay.
Okay, so question 3 is, what are the timescales of the climate feedbacks involved with this component?
Yeah. At least I'm sure I've answered that, but...
Well, for aerosols, it's the same. I mean, obviously they fall out faster, but in terms of their cumulative impact on the climate, it's the same time scale as everything else.
Yes, absolutely. Are the feedbacks global or regional or both?
Both.
I.e., could a global effect be scaled to a regional pattern without running the component at every grid point?
Okay, maybe we go to the last one.
So,
It's dubious, I agree.
So do you want to answer this question really?
That seems more difficult than just putting it in globally.
So, I made wild guesses as to what computer resources were required.
Just to come back to question 3, if I remember the paper by Guy and Eric Bruckner, where they shut down all sulfur emissions in ECAM, I think after 20 or 30 years you had an appreciable amount of warming, of extra warming in the water. It was almost 1 degree Celsius from the direct and indirect effects. So within a few decades you can have an impact from aerosols. It's not a feedback per se. Because of the nature of the forcing, you can have a quick change in the model.
it's faster than that. I mean, they ran to equilibrium. But if you remove the aerosols from the atmosphere, you will have an instantaneous response.
Yeah, well, it takes some time to realize it.
If you go to India and you remove all the aerosols, it's going to be a lot warmer really rapidly at the surface.
If you think of some other feedbacks, I think that they may have different time scales. For instance, the
Scattering versus absorbing.
Well, that's true.
dust, if there is changes in emissions of dust because of changing vegetation, that's not going to happen in the next 10 years. You need substantial change to vegetation, and that takes 50 to 100 years. So.
This is the
I
time
guess-
scale of emissions changes as opposed to climate response.
Yes.
They're saying timescales of the climate feedback. So
That's feedback.
Yeah.
yeah,
But depending on the process, I think.
I think they operated all the scales that I mentioned
Yeah.
here. I don't see how we can do.
Because on this, it's all global, regional. It depends on what you are looking at.
Okay, what computer
Processing.
resources are required compared to the standard AOGCM? Now, the numbers that I was flashing up there were really numbers related to the cost of the atmosphere only calculation. I don't know what it is for the total model. But Olivier thought I was overestimating the numbers for their model, for example. And David, do you have any idea of the cost of the calculation?
Well, so let's say you normally have like 7 variables that you're vectoring around
Right.
the children's street. And then you add another 180 with John
Well,
Seinfeld.
let's
No,
do
no.
the reasonable one.
But in yours, comparing 15 to 25, as you said, the bulk compared to the detail, how much is the difference, for example?
Don't have that number. I know that the dust, which was 6 variables, added 10% to the atmosphere model. So a scheme which got about 15, it's probably 25% of the atmosphere.
That's all.
It doesn't scale
Yeah.
proportionally to the number of prognostic variables. It is an awful lot in the dynamics and polar filtering, etc., which is very costly.
Yeah, I mean, we use like a CFL criterion for the aerosol injection that actually cuts down we have longer time steps for the aerosol injection.
But I mean, so our back of the envelope calculation is sort of 2 or 3% per tracer. That's if all you do is put in a tracer and do nothing else. But then you have to add in all of the extra stuff that is required to.
Right. I'd say that's reasonable for us. As far as the atmospheric again, for simple aerosols. For the mass, aerosol mass as opposed to number.
Right.
Right. For atmospheric chemistry, we have again a simple scheme that I think adds something like 50% to the computer time. I mean, it's been kept really, it's Drew scheme, it's been kept to really simple. But if you go to the Harvard scheme, it's factor 3 times with the atmospheric model.
Is the Harvard scheme is that their chemistry
The
or is that
geochem.
the full geochemistry? So
That would be similar to our full
yeah.
You say
chemistry.
50% to 3 times? That's what you said? It's a lot, no?
Of additional cost, yes,
To the atmosphere model only.
to the atmosphere.
Yeah.
But Claire, I want to clarify. You said add 25% to the atmosphere.
No,
Where
this
did
is
you get that number?
no. It's what
That's an
Olivier was
Adler
saying.
Center model, no,
Adler Center model.
Yeah, right.
But you don't have, like, we have enormous costs of doing, let's say, the SO2 to SO4 oxidation and the scavenging and stuff. That adds significantly to our model. Those things are not
Yeah.
expensive for you?
Well,
I mean, that's
it's
where, even in the
been
old...
part of the atmosphere model for long now. So I don't have the numbers for the set
I mean, you don't have to be, 2 to 3% is what you said, is the cost of putting in the extra tracer.
Yeah, it has
I mean,
nothing to
that
do
doesn't
with the new
include extra
physics that you
physical
have to
aspects,
add.
right? That's just transport and stuff.
Yeah, but-
It doesn't
And this
have
is
to
a
be
transport.
double that. You have to at least double that, probably, for the physical process.
Right.
Because chemistry, for example, what's adding a lot is the photodissociation rates. If you just transport the chemical species, it's not much, but when you have a photodissociation and all that,
I don't see, Clara, yeah,
So just
good. I'm
transport.
glad you're deleting that.
No, I just put
pure
transport.
That's all.
Okay.
But it's,
maybe by 25%.
Now, then you have to add
conservative,
for the
you can
aerosols.
30.
all of them.
and I mean, the other thing is, one of the other issues is like, my experience is the cost of the basic atmospheric GCMs can be very different even for the same number of, with the same resolution. Like, our models tend to be very efficient compared to many other models around the world, our atmospheric models.
but having an idea in the document, putting an idea what are doing the best models can also give an idea for people who are developing
Right.
what they could achieve. Because if people have, for example, adding factor of 3 for chemistry and some other do 50% for the same schemes, it shows them that they have to do a lot of effort on the computing. I don't know.
Yeah, the simple
Depends on the
chemistry.
resolution.
Drew Schindell's chemistry.
T42 by 1. It's you go to T85 by 1.
Exactly. Drew would be able to
Very
get
efficient. So
It,
the IPCC
Yeah, it
would
was.
T85
See, this was always
by 1.
from the
Yeah,
programmers, from the headquarters point of view.
70%.
We had these two approaches. One with Harvard, which was slow and exhaustive, and one with Drew, which was simple and fast. So, of course,
motivate NK.
human nature is such that simple
Sweet,
and fast
too. NK is
is
true.
creeping up to things more complicated and slow.
So Claire, I think my guesstimate is in the old package, not the one that we're currently using, but the package which did sea salt the way the Hadley Center does in 4 dustbins. Maybe we added 100% to the atmospheric model, not 30% to the atmospheric. And now we have something which is more.
I guess
Which is more
this
balanced.
really doesn't account for instance, if you're going to add stratospheric chemistry, you may have to change the resolution of the models as well to do it, which may then add some cost because of just numerics. There may be some computational overhead that comes from that, and from the fact that time step has to be reduced because you have faster processes being resolved, a few things like that that you have to sort of throw into the mix.
Yeah, I put tropospheric chemistry because
Just to account for
stratospheric chemistry, you can, if you start to add chlorine, bromine, and iodine.
And resolution.
And resolution, and I put tropospheric
I
chemistry.
know that when we ran
Drew's chemistry doesn't
our
have
regular
pan.
GCM, and then we had the
Yeah.
stratospheric chemistry.
The hydrocarbons. And
It went
supposed to
up
start
by
putting
five.
that in.
I think it's
Well,
less
there's
than
some
40.
version of
If you have more
Drew's.
pan, and I think it's more, less than 40.
Some version of Drew's chemistry do have tan and
Yeah.
Right.
but not the simplest.
Right, not the one that he was more likely to use for the longer runs. For the shorter time slice things, he might use a more sophisticated.
So, in this case, what takes the most time if you go from 50% to a factor of 3? It's not the transport, because transport is not that much. What is the main difference? The
Well,
J's?
Well, you
Harvard
end up
has
the number of reactions and reaction
125
rates and
species, or
foot-
140 species, or
Yeah.
150 species now.
But is it just
Geochem.
photodissociation stuff, which is
It
the most time?
is the photochemical calculations.
Yeah. But give some.
They have a very efficient food matrix solver, but nevertheless.
That's right.
Time as well.
And Geoschem, when we say factor of 3, also has never been optimized to run in a climate model. They don't care really that much about that.
Well, at one point they
So-
were doing that, and then they sort of gave up.
Yeah, exactly. So which means that never optimized to go very, very, very fast. They never did that, apparently. And they have a very full, very comprehensive chemistry also. So it might be really the very upper limit, I would say.
Yeah, I think those are all fairly rough numbers
Yeah, so-
that are just
Yeah.
Very
indicative
rough.
of what's going on.
And
And some of it maybe we could gain 20% here, 50% there.
And the other point, with respect to what you were mentioning, depends on how fast the atmospheric model itself is running.
Yeah.
So if you're using a very fine resolution model, which you're using up a lot of time on the dynamics, then maybe the chemistry isn't going to be adding proportionally as much as with a coarse resolution.
I don't think it's a function of the resolution of the model. It's probably a function of how optimized and how efficient the atmospheric model itself is.
I would have
But the resolution-
So you think of
Scale.
a 4x5 versus a 2x2.5, the chemistry would be similar proportion.
Yeah.
I think so.
That'll have a lot to do with the computing security.
Yeah, it's going to be depending on which platform you're running on.
Nice systems that the higher the horizontal resolution, the relative, higher the relative efficiency.
I think, Claire, if we're going to use this slide, then we should say simple aerosols can add 30%, and that we're not talking about the more fancier versions.
Rather simple.
Okay.
Yeah, those are the ones that are being
But it's
used
really very-
now, not the
yeah.
ones that could be used in just a year or two.
Very rough estimates.
And then if you wanted to do an indirect effect, terms of interacting with clouds in a sophisticated way with the aerosols, that means that the clouds have to be done in a much more highly time-consuming way, effectively. So then everything feeds back upon
I must say
itself.
some of this discussion has made me worry about is too much effort being put on aerosols and not enough on clouds.
Well, we are
Because
we're
clouds have
swapping
much
all
bigger
the clouds.
effects. Yeah.
The thing is too that I guess maybe that life gets better when we think about clouds because there is only going to be one cloud scheme. No matter what aerosol scheme we have, there will be one cloud scheme and it will be more expensive than the one that's currently in there. And so this fraction will go down because the clouds will go up. So,
I mean,
Well, but
we've
part of the
looked
reason why you're doing the aerosols indirect is because you have clouds. You want to introduce aerosol effects into the cloud microphysics.
We've looked at clouds from both sides now.
what constituent time series would be required from an emission scenario for this component? And we've started, the top part is already dealing with some of these things. Do we want to actually put the, the words down about which one?
What do you mean, for species?
Yeah.
Here?
Either the second bullet could be, as part of it too, it seems like.
Yeah.
Beyond sulfur. So the ones that we know we care about would be a character, it was very consistent with what Steve was saying. I think we know we want to be able to do some characterization of black carbon and organic carbon, and we like it stratified by whether they're fossil fuel or sort of biogenic or biomass burning.
Oops. No, and you want to... And we said that evaluation of current inventory is needed.
Desirability of consistency between historical and future emissions.
Yeah, and consistency.
So do you think we need size resolve emissions, or should the model just take care of it by itself by going from just the emission of SO2 and do the condensation and other processes by itself, coagulation, condensation? I mean, how many of the particles are actually, for sulfate at least, is it mostly as gas or as particles?
With the new aerosol scheme, you will need more information on emissions and how much is emitted as sulfate and some indication of the size distribution of the emissions. As far as we're concerned, that's post-AR5. It's ongoing research for post-AR5 implementation.
And on vertical distribution, by the way.
So I guess, what we're saying is it's unlikely that we're going to do the predictive equations for number, and if we don't, then a knowledge of, let's say, primary particle injection is less important.
Max Planck may do it.
Yeah, because they have that.
They've got M7.
Yes, M7, and there were a lot of details on this.
So it's been tested already for quite a few years. So they probably think it's robust enough to be included.
Well, and Steve Gahn thinks that his is robust enough too, and he believes by the 1st of next year, January of 2007, that he will have the scheme in place in our model. I don't know the cost, and I don't know how it's going to behave, but Steve's going hard at it right now. So.
that's what he wants to do.
It could happen.
Could happen.
I guess what we should try and emphasize then is some of the, what we call post-AR5 may come along.
Yeah, we didn't say much about post-AR5, by the way. Do you want to say more?
Well, we
What
could
it-
just do it in the conversation.
What
Yeah.
exactly do you mean there about that phrase, consistency between historical and future
No,
emissions, which you now actually have twice?
yeah, you have twice, well, oh yeah.
Overly gets stronger.
You're,
Yeah.
you're consistent
We
between
really
the,
care about
What
it.
do you say?
between
Oh,
the
yeah.
top and the bottom
Yeah,
lines.
it's, no, yeah, okay. No,
So
it's-
my feeling was that we're looking for just the fact that there are these two different communities, the
Yeah.
present, the future community producing emission inventories, and the community doing
Well,
pre-industrial to present, and they don't match at the present.
2,000 emissions from one community and the other
don't-
are
don't
going to be
match.
like this.
No,
There's
it's-
a big jump because they don't use the same emission factors.
but David said several things. I've heard this, I think, about us as well. You know, we do variations over the 20th century runs, and then for the future we just keep them constant. Now is that the best way to go?
No.
no.
So how then do you make future emission scenarios that should be used? I think that's an important question actually for this group, because you've got the emission guys here.
But you do it the same way you do it for historical emissions, is that for such a for a specific sector, you know that a fraction of the emissions of fossil fuels are going to be in the form of organic or black carbon. And then you can use that information for the future model, the emission model, and then use the distribution of the emission factors. It just hasn't been done, except for a few groups. And it hasn't been done consistently.
And also, we were told yesterday that the group that put these emissions together, the new emission scenarios, has no real interest in going back and doing the past emission scenarios.
Or
So
at least some of them are incapable of doing that. But maybe other ones are capable, and we should at least get some.
I think Steve said that he had a package of that, but
For
it certainly
sulfur.
wasn't. That it's not necessarily consistent with what the future emission scenario was, because they didn't come only from him. It came from other people.
But also, what also the problem is that since it's different groups, they don't use the same category, for example. What this guy called transport is not what the other guy called transport and stuff like that. But it's not very difficult, I think, just to talk. The problem is these communities never talked in the past, never. Because different labs and different communities. One, I would say the past community is more the IGAC community, I would say. And the future community is more the IPCC community. And so
Claire, with respect to that,
yeah.
question 6 is what is required to improve this component for inclusions in AOGCMs? And I guess I would say maybe that's one of the things which we could name.
Yeah, exactly.
And I mean, we've got to set up our requirements for the emission scenario of people. To some extent, it's been done in a meeting which was in Austria last year.
Yeah, on
It didn't
the
go very far.
on the emission,
Luxembourg,
yeah,
Luxembourg,
the one on
IPCC.
emission factors.
Meeting in Luxembourg on emission scenarios. We didn't go far enough. And then IPCC, the recommendation to IPCC is that we've got a number of preparatory meetings where we're going to address these issues. But the IPCC chairs have been a bit slow to set that up. So I expect it to happen. And for the consistency between historical and future emissions, somehow you will have to do some sort of smooth transition between the two, and that's what we've been doing for AR4 already, because there is.
Yeah, I don't know if it can be just worked up as deltas from 1990s instead of actual emissions or scaling of emissions. I don't know.
Yeah,
But
that's
that's-
to scale the emissions somehow.
I mean, it's all regionally
there is
aggregated.
some big jump.
Yeah.
No, what has happened
It's a
also.
practical matter.
Yeah.
It would be very good to have the two communities.
Yeah,
which are-
and yeah, I should say within Axon, this European network, YASA has started to do a meeting last year, I think, on emission factors, for example, realizing that the emission factor used for the past emissions were different from the one used for the future emissions, and people started to talk, but the problem is, knowing the communities takes a lot of time. And this meeting, I think, in YASA was only 20 people or so. But there is a recognition that it's needed, And maybe, if different community push on this, it might help, I would say. So.
Well, it seems to me like, with respect to this question also, that what we have to do is to acknowledge all these other communities like Accent and like this atmospheric chemistry and climate and Aerocom that are helping you to synthesizing the observations and comparing parameterizations, etc. So in that sense, things are proceeding along relatively well.
So what about, should we say something on observations? I'm not sure. Or parameterizations?
It's beyond my expertise.
Yeah. Observations.
Well, I was really distressed, I don't know how the rest of you feel, by these comparisons that I showed that Colette did with Modus, Miser, and Arrowhead.
Yeah, that's something you've got to do. Yeah?
So the fact that they don't agree to a factor of 2 is really a problem because we've been depending on it.
But it's even worse for chemistry, I would say. When you look at NO2, the same instruments on schema keys are 3 retrievals, and they of the same instrument. They don't agree within factor of 2 of the same instruments. And so, but it's also mean that it's new data sets also that people have to work more on. When you look at URs for the stratosphere, the first year of URs were a disaster, and now it's really good and everybody's using it, so people have to learn how to do that. So
sometimes, like in the case of stratospheric water vapor, it doesn't end up converging. Stay with different observations from different types of instruments.
I know there was a big discussion on that for the W assessment on water vapor, and the conclusion was that nobody knows why it's different, and that's it. So, but I think we have to live with that. So.
Well, okay, so maybe I think we've got a little something for every single question here, and then the thing we should consider is, are there things that he didn't ask questions about that we want to make sure that are communicated to the rest of the group? That we might have already, there are already things on the slides that are like that, but is there anything else that we want to say?
You want something else on requirements?
Well, Olivier, you mentioned this need to specify requirements to the other community, and that there was a little bit of work going on that, but I don't know, I know nothing about that, so if you want to elaborate on it, or if you would want to get up and say a few words about it during the presentation, that would be fun.
You make the presentation.
I don't know how we'll do. How shall we do it? Does anybody have a vote?
Doesn't matter to me.
Doesn't matter.
You draw straws, and whoever gets the short straw has to do it.
You can do it, just if you want to that way.
But at some point, something we didn't discuss is we should also interact a lot with the guys in the other tent. I mean, on the CO2 and the vegetation community. Because a lot of things we say, we need more land use data, and we need that. So at some point...
we've got another session on emissions.
Yeah. Not only on, but on impact it will be the same also. So, yeah, that's right.
If I give that presentation, I may just do a little bit of editing.
Of? Oh, yeah. But when is it? Because since we are only 2 groups.
10:30.
When are we supposed to?
It's 10 o'clock break, 10:30 we do our presentation, this group does its presentation.
Yeah, but we have only 2 groups now, so I don't know how they want to handle that.
Well, and I'm going to be busy at 10:30, so I think at the very least they'll rotate.
I'm going to be busy at 10:30 as well.
Does that mean you're going on a bike ride?
Yeah, probably.
Okay, maybe I should say that.
All the breaks are in the afternoon, just the time when it's going to be raining.
Yeah, it's not really according to the weather.
Morning and evening sessions and afternoons were all yours. Every single day at 4 all afternoon.
Wow. Yesterday was going to be the only morning where it really rained.
No, today they said it should be drier.
Yeah, now.
It's only going to rain for an hour.
But on days like this.